Hello students. So we'll start with arithmetic progressions today. This is chapter 5 according to the CBSE syllabus. So first of all, arithmetic progressions are a kind of sequences. So I want to define first of all what are sequences. What is a sequence? Basically, a, a group of numbers, we can say a group of numbers where there is a particular relationship between each preceding term and the succeeding term. Right? Basically, every pair of consecutive terms in a sequence have a particular relationship. That is what we call as a sequence. That means if I give you a sequence, for example, I give you a group of numbers, say 1, 2, 3, 4, 5, and so on. I can very easily see what is the relationship. I am going on with the natural numbers. After 1 you have 2, after 2 you have 3, 3 you have 4, or you can say that we are adding 1 to each preceding term to get the succeeding term, right? Second one can be 1 square, 2 square, 3 square, 4 square, and so on. Again, it's a sequence. What are we looking at? We are looking at the squares of natural numbers. It's 1 square, the second term is 2 square, the third term is 3 square, the fourth term is 4 square. So obviously we know already the fifth term is 5 square, the sixth term is 6 square, like that, right? So basically it should be the relationship that we are able to understand, and we can always predict the next set of terms. For example, 0 0.1, 0 0.01, 0 0.001, 0 0.00001, and so on. What I am doing here, I am dividing by 10 everywhere, right? Now still I can always tell which will be the next term. I have a relationship here which is there in each pair of consecutive terms. So this kind of relationship, any relationship, gives us a sequence. Now what are APs? AP is basically when we have an arithmetic progression, or AP is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. This is first term. Right, Bacho? So basically what we are doing here is that, as the first example I took, for example, we have 1, 2, 3, 4, 5, and so on. So I know what is this. This is 1. I am adding 1 to 1. So 1 plus 1 will give me 2. And then I am adding 1 to 2. Then I am adding 1 to 3. And so on. So I am adding 1 to each term to get the next term. That is what we are doing. We can have another example. So the second one can be, it's not always 1 can be the common difference. It can be any. Rather, this common difference can be negative, positive, or 0, anything, right? So for example, if I take say 3 and then 5 and then 7 and then 9 and then 11 and so on, what are we doing here? We are adding 2 to each term to get the next term. Here what we were doing in the previous one, we were adding 1 to each term, right? So still I have a sequence, I have a relationship, and I can understand the relationship, so I can always predict the next terms in the sequence. So it is a sequence when you have this kind of relationship, that you are adding a constant to every preceding term to get the succeeding term. We have that as the arithmetic progression AP. It is a special type of one particular class of sequences. I can have D negative also. For example, I can also have, say I start with 3 and I keep subtracting 1 this time. So 3, then 2, then 1, then 0, then minus 1, and so on. Here what I am doing, I am adding minus 1, right? And we can have, say if I just have a 3, 3, 3, 3, this is known as a constant sequence. We call it as a constant sequence because this is also considered under AP with common difference common difference equal to 0 in this case. We call this as the common difference equal to 1. The first term, the notation is the first term is taken as A, and the common difference, what you are adding to each succeeding term, to get the succeeding term, the common difference we take it as D. So we have A equal to 1 in this case, D equal to 1. You have A equal to 3 in this case, D equal to 2. We have A equal to 3 in this case and D equal to -1. And we have A equal to 3 and D equal to 0. This is the standard notation A and D which we use for A and D, the first term and the common difference. Right? What next we have is, for example, I have a question here that in which of the following situations does the list of numbers involved make an arithmetic progression and why? The first one I have picked is a taxi fare after each kilometer when the fare is rupees 15 for the first kilometer and 8 for the additional kilometers. So that means for the first kilometer, the amount I am paying is rupees 15. For this, if I am going 2 kilometers, so for the second kilometer, the amount I will pay, if I have, rather let me write it as for 2 kilometers, not for the for second kilometer, we'll have 8 rupees. If I'm going 2 kilometers, you cannot just go directly for the second kilometer, na? You have obviously covered the first one already. So for 2 kilometers, the amount I'll pay will be 15 for first and 8 for the second. For the third kilometer, for 3 kilometers actually I should write, for 3 kilometers it should be rupees 15 plus 8 was till the second kilometer plus 8 for the third kilometer and so on. So what is my sequence? I am paying 15 for 1 kilometer. I am paying 15 plus 8, 23 for the second kilometer, for 2 kilometers. Then I am paying 31 for 3 kilometers. I will pay 49 if I go for 4 kilometers and so on. So clearly it's an AP. It's an AP with the first term A equal to 15 and common difference D equal to 8. Then the second part. Second part is the amount of air present in a cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time, and the terms are the amount of air present in the cylinder. So if initially we have say X air is there, right? So X quantity of air is there Then after the first pump, you have a vacuum pump, right? So after the first pump, we will have X minus 1/4 of X, because 1/4 of X will be gone. So X minus 1/4, we will have 3/4 X of air removed. We will have 3/4 X of air remaining here. After the second pump, we will have 3/4 of 3/4 X remaining, right? Similarly, after the third pump, we will have 3/4 of 3/4 into 3/4 of X remaining, and so on. So if you have seen, we have the sequences X, 3/4 X, this is 9/16 X, this is 27/64 X, and so on. When we say it's an AP, we can check beta. Clearly it's not an AP. The relationship here is basically multiplying by 3/4. Each preceding term, if multiplied by 3/4, you get the succeeding term. You are not adding something. So still, if we want to be sure, we can subtract beta. common difference D can be calculated by subtracting A2 minus A1 or A3 minus A2, because every set of consecutive terms should give you D as the difference. So 3 by 4 my x minus x will give you, what will you get here? We'll have minus 1 by 4x. And here we have, this is 9 by 16x minus 3 by 4 of x. So that will give you 9 minus 12 upon 16x. So this is minus 3 by 16x. So clearly we do not have A2 minus A1 equal to A3 minus A2. So we have, I can write it here, right? So not an AP. Of course, it's a sequence, but not a arithmetic progression, right? The next thing I have is the other kind of question we get in this one is write the first four terms of the AP when the first term A and the common difference D are given. So we already have A and D given to us. So clearly my first term should be, first term is A, we know that, and the second term we get, we know you will get, this was A equal to 10. The second term you will get by adding 10 to this one. So it should be A plus D. So that will be 10 plus 10, that is 20. The third term you will get, third term is A plus D plus D. So we will have 20 plus 10, that is 30. And the fourth term will be A plus D and another D will be added. So that is basically 30 plus 10 and it's 40, right? So the sequence is, so this implies AP is 10, 20, 30, 40 and so on, right? So in terms say, whatever is n. Now here we will ultimately generalize this thing, but I'll just like to introduce one thing here, beta. So the sequences of the kind A, the second term is A plus D, the third term is A plus 2D, the fourth term is A plus 3D, and so on. So I'll repeat. Your first term is A plus 0D, second term is A plus 1D, third term is A plus 2D. The fourth term is A plus 3D. So that means my nth term should be, nth term, we'll generalize this in the next video for the nth term. Just quickly writing it down. The nth term should be A plus n minus 1 into D. This is the standard formula we use for the nth term in a AP. Right? So we'll come back to this in the next video. So now here, so again we have A equal to minus 1.25 and D is equal to minus 0.25. So I should have, the sequence should be, AP should be minus 1.25 is A, then minus 1.25 plus minus 0.25, then the next term should be minus 1.25 plus, we'll have D plus D. So we can say 2 into, let me write it in the next line. So we will have minus 1.25 plus minus 0.25 into 2. I'm using this thing now. So third term is A plus 2D. So I have multiplied D by 2. And the fourth term will be minus 1.25 plus minus 0.25 multiplied by 3 and so on. So my terms are, we have minus 1.25, then this will give me minus 1.5, then the next one will give me minus 1.75 and the next one will give me minus 2.0 and so on. You can go on with this further, right? Then I have another one for the following APs, write the first term and the common difference. So clearly we have the AP given to us. You have A equal to 3, that is the first term. Now how do we find out the common difference? Common difference, it's a AP clearly given to us. So the common difference should be D should be equal to A2 minus A1, or it can be A3 minus A2 also. In case we have to check whether this is an AP or not, we'll do it in probably the next question. So then you have to check this one and probably the next consecutive pair also. Be sure that yes, you have the common difference same. But right now we have this already given to be an AP, so we can either find this or find this. You will get the same D from both the places. So A2 minus A1 will be 1 minus 3, that is minus 2. Just if you want to, we can do it here also. It's minus 3, A3 is minus 1, minus 1. So it will be again minus 2. So my A equal to 3 and B equal to minus 2 in this case. This one now. Again the first term is A equal to 1 by 3 and D is equal to A2 minus A1. So that will give you 5 by 3 minus 1 by 3. That is 4 by 3. That's it. Then the next one. Which of the following are APs? Now here we need to check properly. If they form an AP, find the common difference D and write 3 more terms. So first of all, in this one, the check is only find out A2 minus A1. It is 3 plus root 2 minus 3, which is root 2. If I go for A3 minus A2, I should get the same difference. So 3 plus 2 root 2 minus 3 plus root 2. So it is again root 2. So this is an AP. So this is an AP with A equal to 3 and D equal to root 2. If I go to the second one. So second one, if I go for A2 minus A1, I will have 0.22 minus 0.2, which is 0.02, and A3 minus A2 is equal to 0.22 minus 0.22. It should give you 0.002, right? So clearly we have A2 minus A1 is not equal to A3 minus A2. So it's not an AP. So not an AP, right? Then the next one. Whenever you have a question like this in square roots, try to factorize it and write it in the simplest forms. Let's see, root 2. And what is 8? 8 I can write as 4 into 2. 18 I can write as 9 into 2. And 32 I can write as 16 into 2 under the root. So this is root 2. This is 2 root 2. This is, if I bring 9 outside, this is 3 root 2. This is 4 root 2. And by now you people must be clear that it's clearly an AP with first term A equal to root 2 and D is equal to 2 root 2 minus root 2, which is root 2. Same difference you will get from 3 root 2 minus 2 root 2 also, right? And for this one now, here we don't know the exact terms. So before reaching any conclusion, just find out the squares and write them exactly. This is 1. 5 square is 25. 7 square is 49. 73 and so on. So now A2 minus A1 is 25 minus 1, 24. A3 minus A2 is equal to 49 minus 25 equal to 24 again. So it is an AP. We can check the fourth one also. So A4 minus A3 is equal to 73 minus 49, which is again 24. So clearly this is an AP. This is an AP with A equal to 1 and D equal to 24. 24, right? And we have in instructions to write 3 more terms for the each AP. So if I write 3 more terms for this one, they can be 3 plus 3 root 2, 3 plus 4 root 2, and 3 plus 5 root 2. Just going on with the same principle. Here if I keep adding 24 to 73, so I should get 73 plus 24 will give me 97. So the next terms can be 97. Adding 24 to 97, we will get 121. Then adding 24 to 121 will give me 145. And adding 24 to 145 will give me 169. Right, we have to, okay, we had to write 3 more terms. So okay, I have written 4, no problem. Now what about this one? The next can be 0.2222, next one can be 0.22222, and another one can be 0.2222, and another 2, and so on. And what about this one now? This one clearly, because we have already decoded this thing, so this is 4 root 2, the next term should be 5 root 2, then 6 root 2, and then 7 root 2. If we want, we can take these things inside, because this was from what we factorized and got. So actual next 3 terms can be 25 into 2 root 50, then the next one 36 into 2 root 72, and 49 into 2 98 under the root. Right, so these are the next 3 terms of the given sequence. Okay students, this was just the introduction of arithmetic progressions. We'll go on with the nth term formula and the sum formula in the next video. Thank you. Thank you for watching students. In case you have any queries, please get back to us on the given email ID. Thank you.